Hello, friends and students. So we are discussing one more topic today, important topic, that is how to read a circuit diagram. Any schematic diagram of a circuit, that is any product, we have to read the diagram, why it is important, and what is the importance in the industry. So first of all, what is a definition? That is, what is schematic or circuit diagram? It is a graphical representation of an electrical circuit. It is graphical representation, a detailed graphic representation of any of the circuit. This is very important topic. Why? Because you should know, the student should know, before going into the industry or doing any project, you have to make a circuit diagram first. So if the circuit diagram is provided to you, how you are going to analyze it, how you are going to see it, that part we are going to discuss today. Okay, so I will go to the next slide. So I will just go to the next slide. Okay, what is the importance of circuit diagram? Building electrical and electronic circuit, this is an important point. If you want to build in any circuit, then you need to know what is circuit diagram, what is there inside. If you are designing any new circuit, or if you are a designer, or you want to produce, or you are making some new circuit, then also you have to design, you have to compulsory go for circuit diagram. Third important point is electrical and electronic circuit essential for troubleshooting. Suppose you are into service industry, then if you are into repairing part or maintenance part, then without the circuit diagram for a bigger circuit, smaller circuits, okay. For bigger circuits, you compulsory need to have a circuit diagram. So that is the importance of circuit diagram. Before going into circuit diagram, what are the electrical circuit that we already discussed in the previous videos? But again, I'm telling you, right? A supply is given, or a electron flow, or completing of a path, right? A completing of the path, right? It should be a closed circuit, that is called as electrical circuit. That you have to keep it in mind. Before going into this second part, important part is that what is conductor and insulator, that you need to know, right? What is conducting element? Like if suppose a PCB is given, there is a track, copper track. So copper track is a conductor. Why? Because it is a copper. It is a copper, right? So what are the copper? What are the conducting materials that you have to know? What are the insulating material? Plastic, rubber, diamond, glass. These are the insulating material, and rest of the all metal things are conducting material. So this part you have to compulsory know. So what makes the electrical circuit complete? The first part is the source. That is, you have to give some power supply. There will be symbolic representation in all schematic diagram that you have to compulsory know. So that I will give you a little detail in this. So first is component, second is symbol, that is power source or whatever it is, whether it can be AC or DC, right? Okay, so like in the circuit, you can see there is a battery or cells. If it is multiple cells, you will draw the diagram. You have to identify whether it is a one cell or a multiple cell. Then switches, whether it is open or closed. There is a symbol, that is symbolic form. You have to compulsory, you have to identify it. Closed switch, open switch. Resistors, box type, two connections, motor, fuse, and so on. I will just give you one more example. So here, suppose there is a resistor. How you are going to identify? A zigzag or rectangle. Just now we have seen a zigzag or rectangle. Capacitor, two parallel plates, right? If it is a polarized capacitor, it will have a symbol. That is, on one side, either plus or minus symbol will be given. Inductors, if it is an inductor part, the inductor part, a coil-shaped symbol, right? A twisted coil-shaped symbol will be there. You can see here in the picture also. Diodes, again, it is a triangle point to line mentioned, as well as LED also. LED also is a diode. So there is a separate symbol for that. Transistor, PNP, NPN symbols. Already we have discussed how to test, how does it look, PNP and NPN. Very important, power source. Whether it is a DC battery gives you DC, AC sine wave, right? Ground, various ground symbols will be given wherever it is there. You can just see in the picture, switches and relays, different operational amplifiers. So many other parts are there, potentiometers. These are the important points you have to remember. Okay, now we'll go to how to identify the connection. This is very important point, because when you want to join one part to another part, or you have to give the supply, you need to know the connection part. That means we are joining one part to another part. So in older convention, the connection was just shown. If one line is touching the other line, it is connected. No, if it is not connected, there will be a jump. Jump means there will be a U-type jump on that particular one. That shows that there is no connection. But new convention shows that when it is joined and there is a dot in the between, that is, if the dark area is there or dot is there, then it is connected, or otherwise it is not connected. This is the new convention, that is connection or not connected. Second important point, direction of the current. So let it be signal, let it be input or output. There will be an arrow, right? Like in diode, you can see in the bottom of this your picture on other side, there's a flow, current flow. It's shown. That is, it is going from plus to minus. As you know, the diodes work in forward direction. It doesn't work on reverse direction. So some direction has to be there, or some arrow symbol will be there. Okay, right. We'll go to the next slide. So see, whenever you learn anything, no, you should read the basics of first very small circuit. Here you can see there is a small circuit which consists of few components, that is switch, diode, resistor, capacitor, LED, and battery. So battery we are taking as a source, and switch, diode, capacitor, resistor, and LED are the components. How it is connected in a circuit. To understand this, you need to start with this thing. So the same circuit we will be doing in the lab today. Okay, I will be showing you the same circuit. Okay.
All right, friends and students. So we have come to the lab. You can see here on a PCB, not on the PCB, it's a breadboard. On breadboard, I have fixed that the same 5 components. Okay. So diode, resistor, LED, capacitor. Okay. And there is a supply voltage, that is a battery. From battery, 2 connections are coming. That is positive. This is the positive. I have given it one end of the switch, and another end switch I have given it to the diode. Okay. And this is negative. I have connected this negative common, that is capacitor, and this LED. Now you can see here the light is not coming. Why? Because the switch is off. Now what I will do is I will just switch on the switch. I've switched on. Okay. Now the circuit is complete and I'm getting a supply voltage. My LED is coming. I'm switching it off again. Now you can see it is off. Okay. The same circuit I have made on PCB. What is the difference between this circuit and this circuit? All the components are almost same, right? Only one component is missing. That you have to tell me what is the component. This is made on PCB. This is on breadboard. So capacitor, resistor, diodes, and LED. Okay. So I will just give connection to this and I will show you this also. Okay. So what is the difference between these 2 circuits? This is temporary. I can remove the components. I can put it back again. Here, I have already soldered it, PCB. I have already soldered. So maximum time in the companies, you will deal with this type of circuit, properly arranged soldering and all you have to do. We have taken a soldering class also. There is a video on soldering class. You can go through the video and you can check the video. So positive end, I'm giving it to this, and negative, I'm connecting it to the capacitor. Now you can see the LED has come. Okay, it has come. Same supply, I'm giving it to this, and you can see that the LED has come. Okay, right. Now you can tell me what is missing in this. You can write in the comments and let me know what is missing in this circuit and this circuit. Here it is there, but here it is not there. You can write in the comments and you can tell me. So what I'm trying to tell you is these are the 2 types of circuits. Now this is PCB. Okay, PCB. One side you have components, another side you have track. I was telling you about the conducting material. These tracks, the solderings are conducting material. Please remember, tracks are conducting material. These are the conducting. The tracks you can see on the small track, there's a conductor. And the open area, this is not non-conducting material. Same here also, non-conducting material, only track where I have put the lid, that is only this thing. Okay, you take any of the PCBs. This is a little bit bigger circuits. This is a complex circuit. This side you have component, and this side you have tracks. Okay, soldering and all. So this type, this is only connection side or track side or conducting side. This side only component side. So schematic means what? You should have a complete circuit diagram. Suppose there is a problem in this. This is a power supply, SMPS power supply. There's a problem in this. How to repair it? You should have what component burnt out, how to check this component, or what is the number of that component. Everything will be given in the schematic diagram. That's why schematic diagram is very, very important. You can see capacitor. So this type of things you will only come to know when you understand the schematic diagram. That's why the schematic diagram are very, very essential and important. I hope you understood. Further, we'll discuss about PCBs, how to design a PCBs. At that time also, I will tell you about the diagram, the schematic diagrams, and the PCBs.
So you start with this. Suppose you want to go for a complex circuits. So there is one project here, Arduino controlled variable power supply. So how to identify the things here? One starting with transformer, bridge rectifier, regulator. What regulator it is? LM338 IC1. It is given LM338. It's a variable regulator. Okay, variable regulator. Rest of the thing, power, capacitor, polarized or non-polarized, resistor, and other, like there is one more resistor, that is VR1. You can see here 5K. That is variable resistor. Then you have Arduino board given on this. It's a microcontroller board, embedded board. On that microcontroller chip is there, and there are inputs and output connection given on both the sides. Other side, it is connected to a 16:2 LCD. That is 16 cross 2 black and white LCD, like liquid crystal display, to get the information. That is, the voltage will be seen in this. So this is a small, little better, like moderate type of a power supply. Okay, so this you have to understand. Okay, so parts, connectors, identification is very, very important. Next slide. For tips for the beginners who are just beginning it, what you have to see in the circuit when you see a circuit, right? Learn to recognize common pattern like voltage divider or RC filters. Resistor to resistor connected together. It will be called as a voltage divider that we have seen previously, or maybe I will tell you in the coming session. RC filters, that is a resistor and capacitor, whether it is connected in series or parallel, that you have to see. So these identification are very important, the component, right? How it is connected, RC or voltage divider. Use simulation software like Tinkercad, LTSpice, or Proteus to practice. So this part I will tell you in the later class. Why? Because these are the software on which you can practice Tinkercad, LTSpice, or Proteus. These are the PCB design as well as circuit designing software that we will discuss a little later, but you can take help from this particular software. Refer to datasheet for pin configuration and internal circuit. This is a very important point. Please remember, all who are going or joining the industry, whatever industry it is, manufacturing or service industry, I have already given you what is the importance of datasheet. Please go through my old videos, the previous videos. I've made a separate video on datasheet. Please go through it and what is the importance of datasheet that you can know. Now, one more important point I would like to tell you is here, that is power supply. Here you can see two pictures, one on the top and one on the bottom. So one is a circuit diagram, another is a block diagram. Sometimes the students or other people will have little confusion. Sir, what is the difference between circuit diagram and block diagram? So circuit diagram is a schematic diagram. It is more detail used for by service industry. Details, it will, whatever information you want, you will get it in circuit diagram. Okay. So block diagram is more about understanding how the system works, right? How the system works, because it is in a block. The complete details will not be provided in the block diagram. So that is the main difference between schematic circuit diagram and block diagram. Okay. I hope you understood this point. One more, I will just give you one circuit and I will just explain you about that particular part. All right, students. Now you can see I have put one circuit diagram. This is a schematic diagram, circuit diagram, not a block diagram. This is all about a motor driver of a car or vehicles, electric vehicle motor driver circuits. So you will find all of the things over here, all the details. Just I'm trying to show it to you. On the left-hand side, top corner, there is a power supply, 5 volt DC. You can see here with some regulators and some capacitors. This is ground symbol. Then again, there is one more part, that is Hall sensor, right? There is a Hall sensor. Hall sensor is for speed sensor and it can control. There is a microcontroller on the top below where the arrows are going out. The supply you can see here, some of them are coming here. Inputs are there, like arrows will be there, and then this is the symbol for the ground and the supply voltage for controlling this. So this side you can see some MOSFETs, pair of MOSFETs, 1, 2, 3, 4, 5, 6 MOSFETs. These are the main driver transistors, okay, which will drive the motor, okay. If it is a single phase motor, it can be 3-phase motor, or it can be a DC motor, right? It can be a BLDC motor. Mostly BLDC motors are used. So I'm just talking about this thing. One more thing is given. There is a sign, there is a waveform here given here. How it will look on the digital oscilloscope, that waveform is also given here, okay. And some operational amplifier, 4 operational amplifier to control the circuits, the different type of circuits, that is this logic gates will be there for controlling the things and all. So I'm just giving you a little idea that how to check the schematic diagram. I have just for that purpose, I have shown you this particular video. You can see switches and everything over here, and you have a variable resistor. So all type of components you will find in here. But before that, you should know what are the components, what are their symbols. It is very, very important.